Hello, my name is Alfredo Lozano, and this is my final project for CISD43 for spring of 2026. And I used the dataset of the credit application dataset and utilized the machine learning technique of k-nearest neighbors. And so the project description was basically I could perform an EDA and then later machine learning algorithm to try to find out if um, the dataset was better or less in performance compared to the machine learning in finding out who was accepted or declined for credit based on a series of different factors. The trouble with this was that a lot of the data set, actually almost all the data set, was I think you call it anonymized. We have no idea what the description of the numbers, but given reading up on some history online, this data set could have possibly come from UCI or an Australian credit application data set, and both might have been created in the 1990s. So we do possibly have some column names, which I did link at the bottom of the report here. So basically, the first step was to perform EDA, do some visualization, and then later do a machine learning algorithm with KNN. And there wasn't really any missing or no values at all that I know of. And then um, after, while doing the EDA, basically just describing printing out the head and getting the information and then creating visualizations. So, and the conclusion for the project was basically that machine learning was a lot better compared to the data set decisions that were possibly made by human employees. Um, and it was about, I think, I assume by 0.30 or more. And also at the same time, while performing EDA, I realized that there may have been some bias from the data set. Um, I almost wonder if maybe that there may have been some kind of business goal to lend towards people who didn't have credit or bad credit or no savings at all, um, or little to no income. So I don't know, but we'll find out, um, guess in time. Um, but this goal for the project was to see what performed better. And so far, to my knowledge, it's the machine learning, but I'll describe further. This is my Jupyter notebook. The same thing as I was only contributor. I chose to challenge myself and at the same time, a bit of a strict schedule. So yeah, basically the problem statement was to go and see if I can grab a data set for a credit application and with all the records, there's different factors like, credit history, marital status, income amount for all the customers in the database, um, or data set, I should say, their expenses, age, uh, overall like credit factors that, like delinquencies and such, and try to see if what performed better, the records in the dataset or machine learning algorithm, which was KNN. And so we have our uh, the, the imported packages. So pandas, numpy, matplotlib, cborm, sklearn, standard scalar, KNN, confusion matrix, and the classification report. And then the methodology was to go in and use pandas to load the data, use matplotlib and cborm for EDA visualizations, sklearn to train the data and split it for machine learning, and then the KNN classifier for KNN classification report for the KNN report. And then the only model I used was the KNN machine learning for classification and regression, and then using Euclidean distance, and then of course standardize the data. So going in, just starting to load the data from pandas, and then to perform the EDA using info and shape. Then we start getting an idea, what data types, how many records, and then of course the shape. And then not just using describe, but I think it's .t at the end, and that's I guess I think it stands for table. And then have everything nice and organized here. So all the different records, their averages, standard deviation, the min, the quartiles, and the max. So after that, listed the column names, and then I chose to rename them. And that way it was just seemed a little bit easier to perform some of the code here. That way I wasn't just making a miscalculation, given everything is A1, A2, A3, and that could be a big mess up, especially if it's late at night. So I chose to rename it and then printing out the head for the first few entries to show the changes. And then using .s null with the sum and seeing that we have no null values, which is good. And all the data types. And then starting to remap things with a new data frame from the class column and between approved or rejected. And that helped with the visualizations in general. Once we started getting the value counts and just seeing, for the first visualization, and then also getting percentages from the data set of how many were approved versus how many were rejected, as we see here in the differences with the visualization using a histogram. And doing the same thing with gender. And this is where it got a little bit difficult because we cannot still tell, for the most part, what gender is regarding what's 0 and what's 1. Is it male or female? Is it reversed? I don't know. There is a pattern that seems to be historical. So the approvals by gender, and not to be biased towards anything. But this is where I kind of did 2 histograms and laid them on top. Gave them different colors. Kept the same amount of alpha. And we see something interesting. So, to my knowledge in history, is that credit utilization is generally lower in some countries for women. So blue versus men, which is higher. Um, I can't say that for every country, because I don't know every country, and this is also could be possibly an older data set, so I got no idea. If this would spell the pattern of which color is male or female, or what is gender B, which is gender A, I don't know. But from what I heard too, is that women are better accountants. They're better at paying the bills. Um, I've also heard men tend to spend way more. I don't know. I'm not too sure, but it's interesting how you can grab data numbers and see how much the credit utilization is. Versus this isn't years, but this is percentages, I believe. So as we continue on, we use more figures, more plots, and then we have next is the amount of years employed versus accepted numbers. And some of these are kind of interesting because I would figure that people would have the lowest number on year 1 or year 0 because it's risky. For some jobs, you don't know where you're going to be in the first 6 months. Will you still be there? I don't know. Year 4 would make sense because you're probably been hired on full time, permanent, tenure, whatever. And then maybe year 8 would be like management, supervisor. So, and that was performed using histogram and the column years employed versus the class with the definition of 1, which is accepted in this case. And like I said, I don't know if 1 is accepted or 0, but kind of just going with it. And then using the D-spine to pull out the grid. All right, so The next thing I try to see is if I can create another histogram and getting an idea of the accepted class of one versus the savings and assets, and just see if what we can get as in terms of the amount of accepted applications. And this is where it got interesting. There was really not that much in regarding assets or savings, and yet so many were accepted. So either this was a company who wanted to lend to lower income individuals or those who didn't have any savings and maybe were just starting out, um, or that just wasn't, there was another factor of why these people were accepted. I don't know. We'll figure out in a little bit. So next thing was trying to figure out what the category of the type of loan was, and got the value counts by the category, and printed out the value counts for each one of these, and it seemed like the highest one was category 2. I don't know what categories these are. I know there's certain standard economic categories of loans, but still, even then, who's to say what they are? It could be the majority could be houses, the majority could be personal loans. I don't know. Could just also be credit cards. I guess it just depends on where the data was sourced from and at what time. So this was using a pie chart. And the next thing, another pie chart to see if the customers had any prior credit. And once again, we don't know what the 1 or 0 stands for. So we do have an idea of the percentages, but they're pretty much even. They're almost even. So I don't think that would be quite the factor yet of what was the contributing factor for approval. All right, as we go down the line here, try to do a strip plot. And I tried initially to do laying both the plots on top or side by side, and that's where a readability issue came into play so much for quite a while. So I chose to do not side by side, but I guess paired vertically. And so we have the rejected and the approved applicants based on I guess the category type. So whatever 2 is, seemed to be the one that had the most accepted or declined. And then we see the amount, which seemed like, I guess, higher numbers were rejected compared to accepted. And this is where we got an interesting thing, because like who would loan 1 or 0? And this is where I had to do a little financial research, where a lot of lending companies or banking companies, I think they call it binning, and the 1 will actually stand for 0 to 1,000, but we still don't know. This is where we have vague data, but we do see at least a pattern. Higher requested amounts of loaned money seem to have the highest rejections. And it seems to be, for rejected, it's about 250. And then for accepted, I think it's 1. It's a little bit hard to read here. Okay. And next, we're going to go into the amount requested versus default and serious, and remarks on credit and who is accepted. So we have our legend here, and the amount of default or serious remarks on the credit report, and then how much was requested. So the green, I'm assuming, is going to be probably rejected, but as you look around here, it seems like as the numbers increase, you're getting more and more orange. So it could be that 0 is actually accepted. And that might be better because, look, I mean, this is an outlier, so we can't really tell, like, hey, this is what our data set is biased on. but it seemed to be a good pattern to follow. The less amount of negative reports on your credit, you might get a better, higher amount of credit. And next, we were going to go into age. And this is something that I did notice when I was in college, in my early years, not now, but was that there was a very negative practice, which I don't know if it still happens today, is that lenders would try to market towards younger people. So I was curious to try to grab the age class and the accepted class and see what I got. And of course, it could be multiple factors saying, hey, like, they're younger because they're starting off a good job or career. I don't know. And there's different peaks and drops in this, but it seemed like around the early 20s seemed to have the highest accepted rates. All right. And then seeing the average, I guess, accepted rate based on married and single, and I guess what they were requesting. No, I'm sorry. The average amount of savings and assets by marital status, and then who was approved. So, of course, having somebody with you in marriage could, boost your chance for a house or a car, co-signer, and then also, you know, double the income. Um, but it didn't seem to vary too much, I think, because I mean, of course, we have non-defined data. I'm gonna throw a guesstimate on this. So 0 would be rejected, 1 would be approved, but I'm not too sure. But as we see here, the 250 is interesting number from before the scatter plot. Sorry, the strip plot. So not too sure. All right, then we have a box plot, kind of like the averages and the quartiles. There's a lot of outliers in both of these, but savings and assets by marital status. So not acceptance rate, but just kind of getting an idea of what these numbers are. It could be 5,000, it could be 50,000. It's hard to say. I mean, there was a standardization of data for this project, but these numbers still were, what is that exactly? Okay, continuing on. Um, Next, we have approval versus rejected by credit behavior. So it's hard to say, but it seemed like good had possibly better approval odds, but I don't know still. It could also mean that 0 is rejected versus 1 is approved. Um, and that's where it's kind of just difficult to say. So it was using, yeah, we were using a lambda function. So kind of packing in the whole function, like two of them into one. Okay. And this is where we get into the machine learning. Basically, since I have no idea the definitions of this data, I could be wrong. So I would turn it over to the machine learning using KNN and then defining the X and Y of class, splitting the data. And this is all using KNN. And then this is where I chose to drop because before where I remapped the columns, like good credit, bad credit, this is where I chose to start dropping these newly made columns in the dataset. Otherwise, there was going to be a big error. It would kick it back, the process back at me and stop things. So same thing for class and credit behavior. I think it just to get rid of the string values and then starting to standardize the data. So I think it's on a value to 0 to 1, and then fitting it into the proper scale, I believe. Applying the KNN, and this is where I chose to have 5, and we'll talk about that later, using a Euclidean distance, the shortest between 2 points. And then we have our confusion matrix, and I chose to do a heat map just for visual appeal. It's not really going to do anything too much. But we start, seeing our not approves, 103, the true one, true not approves, and the true positives. So there seem to be more rejected versus positives. And then, we have our falses, false approved, and I think false negative. Then we have a classification report. We see our precision amounts, the recall, and then the accuracy. So it wasn't too bad. The numbers, it seemed to do a lot better than I would assume based on the percentages from the data set. So it seemed to be a little bit better, if not a lot. And this was using KNN of 5. So I got curious, was there something out there that could help me find a better KNN number rather than guessing all day long? And I chose to have a scale of 31, I think it was. So this is using a grid search pattern. And then it will basically print out what was the best number. Now this is where it gets a little, this is supposed to be like an overall best number, not a single one like I picked, which was 5, and it did just so happen to do good. This one was the best one overall, but it wasn't by much, as you can see. The same process, but with a different KNN number, which was 16. Confusion matrix, heat map, and then the precisions. I think in this regard, 104. It wasn't better by much, and in fact, we had less approvals. So, and then we have 11. So it helped a little bit, I think, to define some false negatives or false positives, and we had less approved. But it's not by much, to be honest. It is still better than the data set. What they said was who was approved, who was declined. And it was a lot faster than having to go through every one of those and get mathematical accounts of who what the percentages of and what were the contributing factors. So the machine learning did it for us, and it didn't need any definition of the columns either. So it seemed to work out pretty good. And that's pretty much what my conclusion is. Machine learning would be better in this case, and there's a lot of things in the world, like in regarding to banking and loans, the first impressions mean everything in the sales world. So, you can do the tries. You might have the best credit score, but you might not look the best that day, or might not be in a good mood. So you might not get the best loan in regards to dealing with somebody in person versus machine learning that just grabs the data and says, "Hey, I can handle this," for somebody, and might have a better chance of getting approval. Now, of course, we always have to be careful because machine learning could also be biased if written different. Um, and there has been, I think, class action lawsuits against lending companies that have gotten in trouble before. So there is some practice to this where it needs to be overlooked, and oversought, and regulated. So and adjusted, so everybody has a fair share in this. So all the references of how to do things from EDA. The Australian credit approval log here, I believe. I think that may have been the column names. Then how to do, box plot, strip plot, pie charts, histograms, and then, grid searches from different projects that did KNN. And then, of course, I think the Australian credit approval data set that I talked about. And then remapping of parts of the data set. That's what we have for the Jupyter here. Okay, next we have RapidMiner, and I'm a little bit new with this, and so I chose to do two, which was KNN and I think it was logic regression. So here's the chart for both of them. I think this is correct. And then our results. Let me start getting into, I believe, I get the visualizations. So I have one better than that. This was interesting. I chose a series of different columns. And from what I can assume is that this is the most contributing columns in general. So I picked these 6 columns here. And we do have one, which was A11. So if we go into A11, if I'm reading this correct, what seemed to be the most defining factor of the accepted or declined was the multiple inquiries and accounts, which I don't know if that's true and if I did this procedure correctly. I heard that can really be a determining factor. If you have too many inquiries, or too many accounts, you will not get you will not get credit. It's like I think not only is it flagged as a security risk, if you have too many accounts, especially revolving accounts, you will not be accepted for credit. And just yeah, um, so and that's what I kind of like about bell curves. Get an idea, and I'm hoping that's true regarding that. But this could also be counts as well. So, and then if we go in further, so that's what we have for RapidMiner. It was a little bit difficult, just kind of grasping that in general, but if I'm correct, that's great. Next, we'll go to MongoDB. So, in general, I like MongoDB because of the amount of just sheer speed and power of it. You can get a lot of feedback really quick with, it seems like with a huge data set. And yeah, so I took the credit application database or data set and imported it in here, and it got some interesting queries, and I'll show you in just a second. So, um, of course, you can always just look it up through the data set, but if you're looking for something that's a particular query type, like age or income or requested amount of loan, then, that may be worthwhile to just narrow it down really quick. Okay, and I chose to do the Jupyter notebook of this because apparently Jupyter is having trouble loading this at the current moment of time, but we do have the numbers and the feedback from it. So we have our imports, Mongo, and then using pandas, connecting to the database, which we did see 27017 right here. And then I just put this here for just reference. That way, not too much confusion. Defining of the database, and retrieving the first 3 records for a query, which we have here, and then getting a count, which was super quick, and then getting a breakdown of how many per each one, which is pretty cool. You just go through a document, category 1, 2, and 3, which is A12, which we have right here, loan purpose category, which is pretty cool. All right. And then just going in and making sure to get the most popular category of loan. There's a column in the counting. And this is just string right here. So, and then we can match it with 625, which is good. Just part of the aggregation. And this is kind of like pipeline is like your template of like a format of how things are going to be listed, which is pretty cool. Very powerful. And then if we go down the line, so we continue further, what I chose to do was see if I could find the maximum number of delinquencies. So the amount of people who had delinquencies in general, not the amount that they had each, but how many people did have delinquencies. And that's taking column A9, which is delinquency, and then finding out 625, which is interesting. So what are these, or not these two numbers are the same, or they're different, and yet they match in correlation with each other? I don't know. That one's kind of interesting. So next we try to go in and try to find one specific customer by using a query, and then using the find one function. And then we get the feedback from the result. It's a very, very long, just all the columns. So this helps in a sense where, we don't have a named, and you just have numbers, but you just have to be very careful. And then now we try to see if we can perform another query by going to a column E13, and then that's amount requested. And then here is where we say greater than 800. Now, whether that's 800, 8,000, 800,000, or 800 pennies, I got no idea. But still pulling the result from that and just grabbing the first 5, we have all the information with the customer ID number, and then whether or not they are accepted for credit, which is under class, and then making it a little bit more organized and using pandas to go in and creating a data frame and printing it out, which is pretty handy. Easier to read. This is all done within a few seconds of just hitting enter, or shift enter, getting our column names, which we pretty much already know already. And then I just want to continue with further querying, was basically taking column A2, which is age, and saying the customers that got money through a loan that was younger than 15. And I think there's actually international laws against that. It's like, nah, you can't do that, And then I found one. It was 13.75. So that's pretty handy, because that would definitely have to be a very big customer service issue there, I would imagine. So you would want to track them down and cover your bases and say, hey, sorry, can't do business with you. And then I just put a limit on it on 10 because in case, there may have been less than 10 or more than 10. I don't know. Next, using an aggregate function with the pipeline that we talked about before, but different. I wanted to see how many, not how many, but what was the oldest person who got a loan, or oldest number that was an applicant, I should say, and the minimum number. Grabbing into result variable with a collection aggregation, and then printing it out if there was a result. And this is our numbers. Highest amount was 80 years old, youngest was 13.75. So that's what I got from MongoDB. It's extremely powerful. And you can organize it well with pandas, so it works well with pandas, it seems. And you can even grab things that you don't need to get all the data. You can get just some of it or the max of it. So that's a joke. So mathematical joke. Anyways, thank you so much. It's been a wonderful time taking the course. Hope to keep improving on this. And I imagine in the future, these types of applications will be very powerful, even more so in the future for more vast amounts of different job fields and careers. So thank you.